Welcome to Big Data Now. TensorFlow is one of the most powerful and versatile frameworks for building machine learning and AI models. But what makes TensorFlow special? It was developed by Google Brain and released as open source in 2015. TensorFlow was designed to handle large-scale machine learning workflows, from research and prototyping to production-ready deployment. In this video, we'll take a comprehensive look at TensorFlow, starting from the basics of tensors and moving to real-world applications like image classification, natural language processing, and big data pipelines. Stick around for hands-on examples you can try yourself, and by the end of this tutorial, you'll be ready to start building with TensorFlow. TensorFlow is an open-source machine learning library. It's designed for building and training models that can handle massive amounts of data. TensorFlow has evolved over time, and with TensorFlow 2.0, it became much more user-friendly while still retaining the power of low-level operations for advanced users. Here's why TensorFlow stands out. 1. It's scalable, running on CPUs, GPUs, or TPUs. 2. It supports end-to-end workflows, from data preprocessing to model deployment. 3. It integrates seamlessly with cloud platforms like Google Cloud AI. Now, let's dive into some real-world examples. TensorFlow's foundation is the tensor, which is essentially a multidimensional array. Let's explore basic operations with tensors. Create and inspect a tensor. Here's how to create a simple tensor and inspect its properties. This is a 2x2 tensor with integers. You can check its shape and data type, which is essential for understanding what kind of data your model will work with. Perform element-wise operations. Let's see how to perform operations like addition, subtraction, and multiplication. These element-wise operations are the building blocks of neural network computations, like adding weights and biases. Reshape and transpose tensors. Data often needs to be reshaped or transposed before feeding into a model. Reshaping and transposing are common in image and text data preprocessing. Handling big datasets is crucial for machine learning. TensorFlow provides powerful tools like the tf.data API for managing data pipelines. Create a dataset. Let's create a simple dataset of numbers and preprocess it. This pipeline doubles the values in the dataset. Such transformations are common in preparing datasets for training. Batch a dataset. Batches are groups of data points used in model training. Batches improve computational efficiency during training. Load data from CSV. Let's load structured data from a CSV file. This is useful for tabular data like customer transactions or sensor readings. Now, let's move on to building and training machine learning models. Build a linear model. We'll start with a simple linear regression model. This model predicts a straight-line relationship between x and y. Build a convolutional neural network, CNN. Here's how to build a CNN for image classification. Convolutional layers are essential for processing image data. LSTMs for time series data. Long short-term memory networks, or LSTMs, are a type of recurrent neural network, RNN, used for sequential data, like stock prices or weather predictions. Let's build a simple LSTM model for time series forecasting. This model predicts the next value in a sequence. LSTMs are ideal for data that has temporal dependencies, such as time series or language modeling. Transfer learning with pre-trained models. Transfer learning uses pre-trained models to solve similar problems, saving both time and resources. Let's use a pre-trained ResNet model for image classification. This approach uses ResNet's powerful feature extraction capabilities while customizing the final layers for your specific task. Data augmentation for images. Data augmentation artificially increases the size of your dataset by applying transformations like rotations, flips, and scaling. This helps prevent overfitting in image models. Augmented images improve the robustness of your model without needing additional labeled data. Early stopping to prevent overfitting. Early stopping monitors your model's validation performance and stops training when the model stops improving. Saving and loading models. TensorFlow makes it easy to save and reload trained models for reuse or deployment. This is useful for deploying models or sharing them across teams. Custom training loops with gradient tape. For advanced use cases, TensorFlow allows custom training loops using gradient tape for full control over the training process. Custom loops are ideal for implementing novel algorithms or debugging. Text classification with TensorFlow. Let's build a text classification model using an embedding layer for text data. Embedding layers convert text into dense vectors, making it usable for neural networks. TensorFlow Serving for model deployment. TensorFlow Serving is a powerful tool for deploying models as REST APIs. This deploys your model as a scalable service, accessible via REST endpoints. In this section, we explored advanced TensorFlow features like transfer learning, LSTMs, custom training loops, and model deployment. These tools make TensorFlow a versatile framework for both research and production. If you found these examples helpful, don't forget to like, subscribe, and comment with the topics you'd like to see next. Thanks for watching.